Welcome back to Maths Playground. Today we'll be taking 5 random questions from AMC 2017. So our first question will be for any positive integer m, the notation m exclamation point denotes the product of the integers 1 through m. What is the largest integer n for which 5 to the power of n is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? We already went over factorial, so this shouldn't be too tricky. So note that we can write 100 factorial as 100 times 99 times 98 factorial plus 99 times 98 factorial instead of 99 factorial. And for 98 factorial, we can just write it as 98 factorial. So notice that we have 98 factorial common in all three. So we're going to take it out common to 98 factorial times well we have we have 1 plus for the 99 factorial we have 99 because we're multiplying it by 99. Then we have plus 100 times 99. So we can write this as 98 factorial times 1 times 100 plus 99 times 100. So now in here we can take 100 out common, so we get 90 factorial times 100 times, 100, because 1 plus 99 is 100. So we get 98 factorial times 100 squared. So now we have to find out all of the factors of 5. So in 100 we have 5 and 25. Those are the only two powers of 5 you're going to find. But since we have 100 to the power of 2, we're going to multiply that by 2, which gives us 4. Now for 98 factorial, we're going to list down all of the numbers that are divisible by 5, which are less than 98. And obviously they have to be 1 or greater. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, last but not least, 95. Okay, so we're going to see, so we have to see how many of these are divisible by 5 and 25. So 5 and 25, right? So 5 is 5 to the power 1, or instead of 25, we can write it as 5 to the power of 2. So if it's only divisible by 5, we're going to write 1. If it's divisible by 25, we're going to write 2, because that's how many powers of 5. So 5 is 1, 1, 1, 1, and at 25, we're going to get 2. But here's the catch. 30 would not be 2 because it's not divisible by 25. It's only divisible by 5, so it would be a 1. Then 1, 1, 1. 50 is 25 times 2, so it would be a 2. 1, 1, 1, 1. 75 is 25 times 3. It would be a 2, 1, 1, 1, and 1. So now let's count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And since we did the 50 already, we're going to do 18, then 19, 20, and 21, 22. So this gives us a total of 22. So we have 22 plus 4, which is 26. Now you don't have to memorize this as a formula. We've got proof in front of your eyes. Okay, next question. So, in the right triangle ABC, AC is equal to 12, BC is equal to 5, and angle C is a right angle. A semicircle is inscribed in the triangle as shown. What is the radius of the semicircle? So, by using the Pythagorean theorem, we can find out that AB is equal to 13. So, and we need to find the radius. So we can make the tangent point where AB touches the semicircle. We can call that point D, and the center of the circle O. So if we make a line OD, that would be the radius. So um so this would be a right angle because wherever the radius in the circle touches the tangent point, the tangent line, it forms a right angle, and um and also BC and BD would be equal because they're both tangent to the circle. And if we have the circle over here, it's not perfect, and we make two tangent lines that meet up over here. And they also start at the same points. It, it makes an isosceles triangle because they touch the circle at the same level. The lines start at the same level and they end in a point, so it just makes these equal. There's a better way of proving it, but I guess it's pretty long, so we can't go through all of it. So, BD would be 5, which gives us that AD is 8. So now, since both angle D and angle C are right angles, and we have that triangle AOD and triangle ABC are similar by angle similarity because angle A is common. So this gives us So if OD is the radius, we can call it R. So R by 8 is equal to 5 by 12. So 12R is equal to 40. And we need to find out R. So we have R is equal to 40 divided by 12, which is equal to 10 by 3. So that's a radius, which in decimals would be 3.333 and so on. That was pretty easy, short, but we also have a lot of things to prove. Okay, so now our third question. Each day for 4 days, Linda traveled for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. Each day after the first, her speed decreased so that the number of minutes to travel 1 mile increased by 5 minutes over the preceding day. Each of the 4 days, her distance traveled was also an integer number of miles. What was the total number of miles for the 4 trips? Okay, so um, so we know that the number of minutes each day for 1 mile must be a factor of 60 because because it says Linda traveled for 1 hour. So if we listen all the factors of 60, we have 1, we have 2, 3, 4, 5, sorry, 6. We don't have 7, not 8, not 9, 10, not 11, 12, not 13, not 14, 15, and then we have 30, and we we also have 20, just in case I forgot that. 30, and we have 60. So now if we go through the whole list, we we need numbers from these lists, 4 numbers from these lists, which have 5, which go up by 5, exactly 5. So we have 5, 10, 15, and 20. So if you look through all of these are the only 4 numbers that go up by 5 in all the factors of 60. So what was the total number of miles for the 4 trips? So each of the 4 days, her distance traveled was also an integer number of miles. So the first day it was 1 mile, 2 miles, 3 miles, and 4 miles. So our answer will be 4. That was pretty fun. Okay, our second to last question. Almost there. In the figure shown, US and UG are line segments, each of length 2, and an angle TUS is equal to 60 degrees. Arcs TR and SR are each 1/6 of a triangle with radius 2. What is the area of the region shown? Okay, so if we continue UT and US to make an equilateral triangle with side 4. So we have, let's call this X and Y. So we have each side is 4. So now we can find if we can find the area of UXY, then we subtract the areas the of 1/6 of circles SRX and GRY. Then we will find the area that we have to find. So area of an equilateral triangle. So we have an equilateral triangle right here with side S. And let's make a perpendicular line, which we can call H, height. So using the Pythagorean theorem, in each of these right triangles, we have S squared is equal to S divided by 2 squared plus H squared, because one of these sides is S by 2. So H squared would be S squared minus S squared divided by 4, which, which other way around we would, not other way around, which we would end up with 3S squared divided by 4. I'm done stammering. Okay, so H would be S root 3 divided by 2. So now, if we have to find the area of the triangle, which we can call A, that would be height, which we just got S root 3 divided by 2, times S divided by 2, because it's height times base divided by 2. So we get S squared root 3 divided by 4. So now if we apply this over here, we're going to get 16 root 3 divided by 4, which we'll end up with 4 root 3. Now we want the area, and we know that area of one circle is by r squared, So here's the area of this circle. Any one of these circles would be, we know that the radius is 2, so we would have 4, 5. So since each of the 1/6 of circles, well, they're 1/6 of a circle, so these together. So if you add the areas of these together, we would get the area of 1/3 of a circle. So we would have 4 root 3 minus 4 pi, but divided by 3, since both of the areas together would make 1/3 of a circle. And that's your answer. 4 root 3 minus 4 pi divided by 3. 4 pi. That makes me hungry. Wish I had some pie now. Well, that's it for this question. Well, unless there's some genius who can simplify this, then it's not the end. But obviously I'm not that genius, so for me, that's my answer. Okay, our last question for today. An integer between 1,000 and 9,999 inclusive is chosen at random. What is the probability that it is an odd integer whose digits are all distinct? Okay, so let's find out how many numbers there are that are 4 digits and they're odd with all distinct digits. So for the last digit, so we have 4 digits. So we have 1, 2, 3, and 4. For the last digit, we have um 5 choices. We have 1, 3, 5, 7, and 9. For the thousands digit, we can't have 0. We can't have the number we just chose. So we would have 8 choices left. But for the hundreds digit, here's the catch. We can have a 0, so it would also be 8. But then for the tens, we would have 7 left. So this gives us so we have to multiply because for each of the 5 choices we have 7 options for the tens, 8, and for each of those we have 8 options for the hundreds, and for all of those we have 8 options for the thousands digit. So this gives us a total of 2240. So to find it says what is the probability, right? So we would have 2240 divided by 9,000, right? Which is also equal to 56 divided by 225 if we simplify it. So that's your answer. 56 divided by 225. Hope your brain isn't bursting, because mine is about to. But it wasn't that tricky. Probability. See you next time.